In this video, we're going to do the example of diastereomers for C5H10. So don't forget that diastereomers refer to same bonding sequence at different spatial arrangement. And we're going to talk about specifically cis-trans diastereomers. So C5H10, that is an alkene. You can also represent it as a cycloalkane, but really when we talk about our cis-trans, we're really referring to our double bonded alkenes. You can theoretically have them in cyclical compounds, but we're just going to deal with them on a linear double bonded sort of way. So we have 5 carbons. So I'm just going to draw this out like this. So we'll do CH double bond, CH double bond, C, and then that would be H, then H2, H2, and then H3. So that's 1, 2, 3, 4, 5 carbons. And you'll notice that the way it's drawn here, you wouldn't really be able to have any cis-trans. And that's because on this carbon here, if we were to draw this out, we'd have 2 of the same groups like this. And then here you have 2 different groups. On one of the carbons, you have 2 of the same groups. So you couldn't really have cis-trans with it drawn that way. So that wouldn't really be one of our considerations. So I'm going to try to move the double bond over and draw it like this. So I'll do CH3, C double bond like that, then CH, and then CH2 and CH3. And so now, if you try this out, you'll notice that you can draw it like this. So we'll draw a double bond first. We can put both H's on top there and the larger groups at the bottom. In other words, on the same side. So CH2, CH3. And so what we have here, it looks like, since the 2 larger groups are on the same side, that would be the cis version of this molecule. And then we could also have it where the larger groups on opposite sides. So I could do this up here instead, the H here, this remains here, this over here. So the larger groups are on opposite sides of the double bond. So this is a trans version. And so I can call this molecule here. So it's 1, 2, 3, 4, 5, trans pent 2-ene, because it's on carbon number 2. And then this one over here would simply be cis pent 2-ene, because again, the double bond is on carbon number 2, but it's a cis version of it. Or you could use the letter notation. I just want to show you what it would look like if we were doing this as line diagrams. So the trans one is pretty straightforward to draw. You just draw it. So 1, 2, 3, 4, 5. Put your double bond in. And this indicates trans because if you think about it, your carbon group, the CH3 group, this one here, is down here, and then the other group, this group here, is essentially here and here. So it's on the opposite side of the double bond. And usually when you draw trans, you're going to see it in this zigzag sort of form. But if you want to draw this in its cis form, here's our double bond, like that for the methyl group. And then for the little 2 carbon part there, we could just do like that. So notice you can see both groups point down, and they're not shown here, but the H's would be, you don't have to draw these in, but just to show you, the H's would be here and here, and then here you'd have H there and there. So just goes to show the groups are on opposite sides. The H's are on opposite sides there too. Here H's are on the same side, groups are on the same side. of the double bond. So it's very easy to see the cis version in one of these molecules because you can see both big groups pointing either both down or both up, whereas the trans version makes that little zigzag sort of shape with it as well. So in this video, we saw how to draw the diastereomers, the cis-trans versions of C5H10. You'll notice off to the side here, we have a collection of the different isomers for C5H10. We have both the constitutional structural isomers, which is where you change the bonding arrangement. So you can see these are all the different types of constitutional isomers that you can get from C5H10, treating them like double bonds, treating them like linear alkenes, cycloalkanes, so a variety of different molecules that you can get there as your constitutional isomers. And then for your other isomers that we learned about, the stereoisomers, or as we would call them, if you remember from the previous lesson, we have our isomers over here. We have stereoisomers, and then one of the types is diastereomers. And so for our diastereomers specifically, we can have the cis and trans version, other way around, sorry, trans and cis version. You could also have cis and trans in the cyclic compounds. You can see both of them point towards us, whereas here one points towards us and the other goes away from us. So this would be the cis version, this would be the trans version in the cyclical structure, but we don't really discuss that too much in grade 12, but it is a possibility. And then another type of stereoisomer that's different from an enantiomer, or that's different from diastereomer, is called an enantiomer. It's where you have mirror images of each other. So I didn't teach that yet. You'll see it in another video where sometimes molecules can be mirror images of each other. They're not the same molecule anymore. They actually behave differently biologically in the body, oftentimes chemically as well. So you can have mirror image molecules of each other, and they're actually a different type of isomer. And it's still considered a stereoisomer because it's spatial. It's just a different 3D arrangement, but the bonding sequence is still the same. So this is a great diagram because it really shows you your constitutional isomers versus your geometric isomers. That's another word for stereoisomers. And within the stereoisomers, that includes the diastereomers, the cis-trans, and the enantiomers, the mirror images of each other. And we'll see that in more detail in the next video.